Hello, everyone. My name is Winfred Amoako. I am the Growth Marketing Lead here at Arkieva, and I'm going to be your moderator for today's webinar. But before we get started, I would like to do some quick housekeeping. That if at any point in time you have any trouble hearing us, please let us know by using the chat feature in the GoToWebinar window, and we will be sure to assist you. We would also reserve a few minutes at the end of the webinar for questions. So please feel free to enter your questions as you think of them using the GoToWebinar questions window. And we hope you take a few minutes at the end of the webinar to complete our feedback survey to help us ensure that we get the most out of our webinars. So the topic for today's webinar is going to be how to create an integrated stocking policy for your organization. And our presenter today is going to be Peter Murphy. Peter, can you please introduce yourself to our audience?
Sure. Thank you, Win. My name is Peter Murphy. As he said, I've been with Arkieva for a little bit over 20 years now. My role is as a practice director, which means I lead a team of consultants that have responsibility over some of our delivery of solutions for some of our customers. And I'm excited to do the webinar today.
Awesome. Thank you so much, Peter. And we are very excited to have you join us today. So for the benefit of those who are new to Arkieva, we would like to give a short introduction on who we are. Next, please. So at Arkieva, we believe that improved business performance starts with better planning. Next. As a result, your Arkieva team has only one goal in mind, which is to ensure that you achieve your better planning goals without forcing you to fit a mold. So we celebrate your unique business processes. And how do we do this? We do this by ensuring that we do this by creating the process with one question in mind, which is how can we empower you with a better planning process? So our goal is to put you in the driver's seat to steer your improved business performance goals. So this gives you the power to keep your business processes intact. Next. So to provide a quick overview on the solutions that we provide here at Arkieva, I would like to walk you through this ecosphere of Arkieva. So Arkieva One Plan Sales and Operations Planning solutions are used today by over 17,000 users worldwide in the process, chemical, food and beverage industry, as well as the consumer packaged goods industry, to plan supply chain operations for product revenues of over $50 billion. So over the years, we have expanded our reach. Arkieva is now a global supply chain planning software provider with offices in North America, Europe, and Asia Pacific. So in order to, I would like to provide a quick overview of how we define our One Plan S&OP solution suite. And we define this as an integrated demand-driven sales and operations planning process for dynamic business performance. So it provides cross-functional synchronizations across companies, starting from integrated financial planning to demand, inventory management, to create a more dynamic S&OP process using real-time dashboard. So in today's webinar, we shall be centered on optimized inventory management feature of Arkieva. And this product is part of their inventory planning solution. Next. So to give an overview of what the Arkieva inventory management solution is all about, so it comprises of 3 different solution features, which is the inventory planner, inventory analyzer, and the multi-echelon inventory optimizer, which is used to identify optimal inventory levels by combining different factors to create the right safety stock levels, including demand variability, desired service levels, and lead times. And so this equips planning teams to visualize uncertainties from a business context and helps to drive decisions. Next. So to hone in on the features of the Arkieva inventory management solutions, this solution helps you to plan, analyze, and optimize the supply chain network, which is amazing. But then we also want to talk about the robust inventory scenario building feature, which helps you to anticipate and plan for different scenarios. This helps you to gain, excuse me, this helps you to gain a broader overview on how your planning sessions can, how you can see how it affects your overall supply chain planning process. And it also provides an advanced inventory and analytics feature from Arkieva, which allows businesses to quickly identify pockets of inventory that hinder cash growth rates and areas where inventory needs to be increased. So this helps you to find out how much cash you can free up right now with Arkieva's solution. So with all this being said, I would like to move on to the agenda for today, and I will hand it over to Peter to kick off the webinar presentation for today.
Okay, thank you, Win. So let's take a look at today's discussion topics. What we're going to be looking at today is a couple things. At a high level, we're going to look at stocking policies and replenishment policies. From the stocking policies perspective, we're going to frame it in the context of the customer order decoupling point. We're going to see where we are in a simple supply chain and how that then determines how we stock our goods. We're going to take a step back, look at inventory in general, and then do a deeper dive into safety stocks. On the replenishment side, we are going to look at the EOQ calculation and then look at replenishment from the standpoint of ordering frequency versus lot size. All right. So this picture shows a simplified supply chain, and it's going to be useful for framing this discussion. The customer order is simply the point where the order arrives. The customer order decoupling point is simply where the order arrives. Now, one example of this is make to stock. Product is at the warehouse and customers order it from there. Now, having the right products in the right warehouses at the right time is an ongoing challenge. I'm sure many of you are aware of this. That's make to stock. Another one is assemble to order. In this situation, the order arrives when the final product is in an unfinished state. This is commonly called postponement. It will take a little longer for the customer to receive the product, but this should translate into lower costs for the consumer. Why? Because holding inventory at this unfinished state minimizes the risk of making the wrong finished good. So the producer is then not wasting money. Forecasts for the unfinished product will be more accurate than the finished good. And that again is a savings that you can pass along to the customer. The next stocking policy is very popular, make to order. So this means that the order is arriving with only the raw materials there to make it. Manufacturing does not start before that order arrives. Products sold this way minimize the need for inventory. They tend to be more specialized or sold more infrequently. And lastly, we have engineer to order. Engineer to order is a bit of an outlier here. This approach tends to be used on highly customized products that often begin with customer specs. This process may not use any existing inventory at all. So let's look at the customer order decoupling point and make some general observations. So here we are. I put the decoupling point right in the middle just to make the chart look nice. In general, the farther we are to the right towards the warehouse, there's a number of things that we can determine. Inventory costs are higher. More product is is owned by the manufacturing company, more inventory is in stock. Production costs are lower typically because we can take advantage of longer, more efficient production runs. For the customer, there's shorter wait times. And the other piece of this is there's going to be a greater reliance on forecasts because, again, we have to maintain the stocks of inventory at the far end. All right. So the policy a company uses is often chosen for them by the market or by their customers or their competitors. And that's not to say it's completely one versus another. Some companies, have kind of a balanced portfolio. Some are make to stock, some are make to order. It really depends on what is best proposition for that particular customer. And we're going to be circling back to this question a little bit later. Now, we're going to be making two assumptions that I want to call out. The first one is that make to stock, assemble to order, make to order are all policies that maintain inventory. So finished goods, components, raw materials, respectively. So in any kind of analysis we're going to do, it's going to be applicable to either of those supply policies, inventory policies. The second thing is that we're going to focus on a single location. And by a single location, I'm really referring to a single echelon. We're not going to be focusing on a more complicated network that typically makes up the whole supply chain. All right, let's have a look at a simple sawtooth inventory picture. We start over on the left-hand side here. So we have got time on the x-axis down here. So if we start at time equals 0, we have one lot size of inventory. And demand draws down slowly at a very steady rate until we get to the reorder point, which is this dashed line here. One lead time later, so this amount of time right here is how long it takes for the order to arrive. And just as we hit 0, the order arrives and our inventory bounces back up to 1 lot size. So there's a couple things I want to point out. One is that the average amount of inventory that you have is actually going to be equal to the simple way of looking at it is it's halfway between 0 and the full lot size. But that's just because of the simple sawtooth pattern we have here. If we look at each one of these time spans here as one cycle, then the average inventory is actually the demand during that cycle divided by 2. So that's something to take away. Of course, this kind of simple, very regular pattern does not match reality. Demand and lead times are going to vary. So if we take a look at a new situation, here's where I'm calling now. And in this situation, we have the drawdown of inventory at a much faster rate. And as a result, when we hit the reorder point and issue our request for more product, it's going to take that same amount of lead time, but what happens is that we are missing a considerable number of orders. And this is something that we're going to want to avoid for obvious reasons. So let's take a look briefly at some of the reasons why we're going to be holding inventories. Strategic stock, in process or in transit stock, anticipation stock, safety stock, and finally cycle stock. Now, I'm going to touch on each one of these in the coming slides. The first three, going from the bottom up, I'll just kind of define them and explain where they are used and where what purpose they serve. And then, as noted in the agenda, I'm going to do a deeper dive into safety stock, and then finally cycle stock, because that's the context in which we're going to be discussing replenishment. Okay. All right. Strategic stock. This is held for strategic reasons, and we might look at this in terms of either risks or as opportunities. So let me give an example. Let's consider a supplier that may be heading for trouble of some sort. Maybe their balance sheets don't look good, and there's some expectation that they'll be going out of business soon. So if they are your supplier, you should consider building inventory to protect yourself and your production supply chains, right? At any point in time, they may no longer be able to serve you. So in that case, it's a risk that you want to protect yourself against. You build the inventory to manage that. And I'm sure at the same time, you're going to be looking for a new supplier. Now, if that supplier is your competitor's supplier, you may decide that it is worth building inventory as well. Now, potentially your competitor is not going to be as well versed in planning as you are. That supplier may go out of business and might really impact your competitor. So potentially there is a chance to expand your market if this were to happen. So that's strategic stock. Next, we look at stock in process. This is stock that exists because the production or transportation process takes time. It's just as simple as that. A good rule of thumb is that the stock in process is going to equal the average demand times the process lead time. And two things I want to point out. One positive, one negative. If you are seeing that the stock in process is increasing, it could be the result of a couple different things. Sales are increasing, or the goods are staying longer in production or in transit. You should be able to tell pretty easily if the sales increasing is what's the cause of it. If not, it would be a good idea to evaluate the throughputs on different aspects of the distribution and production system. Okay. All right, anticipation stock. You can think of this as the purposeful, forward-looking imbalance between demand and the ability to supply at the needed levels. The classic example that I always think of is the air conditioning company that they continue to work through the winter so that they're ready for summer demand. Because when July hits, they just don't have enough capacity to keep up with demand. So smooth the production, anticipate the coming demand, and build inventory for that. Okay, safety stock. In short, safety stock protects us against variability in demand and lead times at a predetermined customer service level. So all three of those components are what factor into safety stock. Safety stock can be expressed in terms of units or converted into days of coverage. So by that I mean, if you consider one particular product at a location, right? We could work out the math and come up with the thought that we need 860 units to maintain safety stock at a 90% coverage. Those number of units could also be expressed as a month of coverage, or 2 months, or 88 days, whatever it might be. So the two things can be translated one to the other. So I'm showing this slide just to remind you what happens when the demand was higher than expected. We missed some orders. We're going to look at this in a little bit more detail. So what we have here in this middle line here is forecast sales. And specifically, it's the, this chart is showing time on the x-axis and stock, the amount of product that we have on the y-axis. So what I think of this is actually the inventory drawdown as a result of forecasted sales, right? If sales are low, then we are not drawing down inventory as much as we would like. And so it's a more shallow slope. In any given cycle, this being the cycle between here and here, actual sales are going to be higher or lower than expected. It's the likelihood that it's going to be that forecasted amount time after time is unrealistic. But the misses, the lows and the highs, they're going to cluster around this average forecasted value. And they're going to do it in a way that is normally distributed. And this is the basis by which we're going to be able to calculate what safety stock we should maintain. One way to look at this is to ask, how much additional inventory should we keep to protect against this non-blue section in here? See this? Any amount of high sales that hits at the 0 line or above is great. It doesn't impact us negatively at all. But if for any reason the sales are higher than that and we dip into this area here, we're going to miss sales. So what is the service level is really the question that we're going to be asking that protects us from that section there. In the same way that we were looking at demand variability, we also need to look at lead time variability. This is, again, normally distributed here. These two things are independent, and we can put that together. So the two parts that you can see here, they're coming together. The demand variability, the lead time variability can be put together into a common safety stock formula that looks like this. K is the inverse of the standard normal distribution for a given customer service level. But there's a lot of words there, but essentially, if you tell me that a customer should be served at a level of 95%, I can tell you with an Excel Excel formula or many other kinds of things we can look up what that K value should be. These things here, this is going to be the average of the lead time. This is the standard deviation of demand squared. This is the mean of demand squared, and this is the standard deviation of the lead time squared. So what's the relationship between inventory and customer service level, CSL? This red line here charts that relationship. It's an exponential curve. So what that suggests is that when we're going from 85 to 87% in terms of improvement of customer service, it's only going to cost us, if your eyes are really good, you can see it's going to cost us just about 2 extra days of inventory. However, if we're to push it from 95% to 97%. There, because we're much more on the vertical end of the exponential curve, we're going to go from 60 something, I think we go up almost 50 additional days of inventory for the same improvement. So as we're thinking about this, I think it's very common for management, for customers to want as high a service level as possible, but we need to recognize that the higher we go, the more cost it's going to take. So how do we do this wisely? Segmentation of products is a great way to start. If a product has high sales volumes or margins, we don't want to run out of it. Keep a high service level. If variability is high, or if forecasts are usually bad, we like to call that unforecastable. Maybe there's just not enough historic data or market data to indicate how it's going to behave in the future. It's not worth the money to keep a high service level on that. Customer counts, order counts, product life cycle types of behavior, all that's going to provide insight into whether a high service level is warranted. So we have here something called the turn-earn index. Segmentation of products is also going to lead to questions of whether it's worthwhile to hold inventory for something. It's not just a question of high service level. Maybe we want it to be so low that it drops to zero, essentially. The turn-earn index, which is the margin percentage times the inventory turns in a year, is that index. And what we're going to be looking for is something in the range higher than 120. So for existence, if you've got a 2% margin, you want to turn this at least 60 times in a year. 60% margin, that's great. You don't have to turn it as many times. 2 times should be sufficient to warrant having that product around. If a product cannot achieve this, we really should consider a make-to-order policy for that product. Okay, cycle stock. I just want to point out a few observations here. I'm bringing this picture up again because it's valuable, I think, to consider in this context. Unit cost goes up when the replenishment lot size decreases. If you're ordering a whole truckload of widgets, the unit cost is not going to be very high, right? Lot sizes are going to define the cycle stock. The higher you are in the lot size purchase, the longer it's going to take to draw down. Lot sizes often are imposed by the supplier, and that's something that we really haven't talked about. It's not always in our control what lot size we're going to be buying. And the lot size also influences the number of inventory turns that you're going to be able to do within a year. Now, there are two factors that are really most important in calculating inventory costs. One is the ordering cost, and one is the inventory holding cost. And we'll be talking about that in more detail momentarily. All right, replenishment policies. So let's take a look at holding costs. Holding costs can be significant. The general rule of thumb is that it amounts to about 25% of the inventory's annual value. So you can see here, there's a breakdown of values, cost of capital, insurance, handling, the various categories we have. And there's a range there from low to high. In this case, we're showing potential high values of up to 50% of the cost of the product. And it really is, it's a function of where the warehouse is, you know, the cost of capital at that time, the risk of obsolescence. You know, there are certain products that, you know, fashion, for instance, fashion clothing tends not to last very long. So it really is a function of the market that you're in. So what I want to show is how the cost of holding and the cost of ordering can come together to form this economic order quantity. So I jump ahead, I give you the solution to the problem right here. So the economic order quantity is commonly called Q, and it's going to equal 2 times the annual demand times the ordering cost divided by the holding cost. And we take the square root of that. Now, if we look here, the holding cost of holding is this line right here. It's a linear curve. The more you hold, the more it's going to cost us. This down here, this curve is the cost of ordering. That's the ordering cost for any particular order, and we're going to multiply that by the annual demand by the order quantity. And when we sum up those two costs, ordering cost and holding cost, we're going to get this green curve above. The minimum is just going to be here, and I think a little bit of calculus later, we come up with this economic order quantity. All right. I'm going to run through one example and make note that this is the economic order quantity, and my example is going to be centered on the economic order period. All right. We're going to use the same formula that we had before. So here we're looking at the number of weeks of inventory that are represented by the EOQ value. Now, in this example, we've got a yearly demand of 10,000 pieces. So divided by days in a year, and we come up with about 27 units per day. The ordering cost we know is $20. The holding cost on this is 15% of the product cost, and the product costs $5 per item. So essentially, plug these numbers into the formula, and we come up with the Q value of just about 730. Now, that's the total value of the units of Q, but again, we know how many will be consumed in any particular day, so we divide and we come up with a value of just about 4 weeks. So the economic order period for this example is 4 weeks. Okay. Okay. So we have 4 replenishment strategies we're going to look at in detail. These are going to vary by lot size on the left and ordering frequency up here. In both cases, they are either variable or fixed. So let's look at the fixed ordering frequency first. We've got economic order quantity, fixed, periodic order, reorder point, and mixed model. Focusing first on this one, in general, I'm going to say this. It's a little bit of a bold statement to say that this is rarely used, but I think I think that there's some truth to this. Is it likely that on a fixed schedule, let's say every month, you will look at your inventory and say, okay, put in 1 truckload of order, and it doesn't matter what your inventory position is at that point in time, you're just going to order 1 truckload. It's really just not that practical. It might be in the case of contracts, but generally no. The other thing I want to point out is that inventory systems that I've been working with for quite a long time, they track inventory levels pretty well. It's essentially daily snapshots that we're able to read into Arkieva. We really do have a good sense of the day-to-day fluctuations and where we are on any particular day. And this is going to minimize the need for these fixed frequency reviews. Here we're looking at the ordering frequency being variable. So we've kind of looked at this already. When inventory draws down, it hits that reorder point threshold and a fixed lot size is ordered. This is a very popular one. This has some key benefits. Number one is that it adapts to changing demand patterns and it tries to keep levels low. This next one is the periodic order review. In this situation, the frequency is fixed and the amount ordered is variable. So what that means is that we're going to identify some maximum inventory level that we can hit, and when the next period comes around, we review where we are in terms of inventory position. We submit an order that brings us up to that maximum level. One thing I want to point out about this is from a supplier relationship perspective, this can be appreciated because if a supplier knows that an order is going to be coming in on the 3rd day of the month from you every month, they're able to prepare for it. They may not know the exact number, but they can probably adapt to that a little bit more easily than trying to break into some other production run that they have going on in order to submit your request. This last one is the mixed model. In both the ordering frequency and the amount ordered, it's variable. So the question is, where does the guidance come from? Forecasts, either human or automated, are going to play a big role. And we're really going to be depending on a high degree of accuracy with something like this. These models may also be linked to supply planning models, which consider complex constraints like production and distribution capacity. So this is it's a more sophisticated model, but it can really drive really I'll say an optimally low amount of inventory based on forecasts that you have. All right. Now this here is the min-max model. We kind of touched on it a bit, and there's 2 things I want to point out in this. One is that if we look at the words, the text part of this, The minimum level is the reorder point, right? We get down to the, inventory is drawn down until you hit the reorder point, at which time you're going to submit an order of the EOQ. And that should bring you up to the maximum level that you are. Now, this chart is a little bit confusing for one reason. One is that it shows the inventory on hand, which is down here, which is essentially what we've been assuming up until this point, or at least I've been assuming it. But there's also the situation where we have this inventory point. And inventory point is going to include both the physical on-hand inventory plus what is on order. And if we're going to be concerned about hitting a maximum, we really want to be aware of where we are with respect to the inventory point. We don't want to, we want to have visibility of what might be arriving the next day after an order arrives, which may put us really, high above our maximum level. So that is, that's the reason behind the introduction of this additional band of information. All right. Reorder point. Reorder point is equal to the safety stock plus the demand during lead time. So safety stock is this value here up to this line right here. Sorry about the, this SS should be over here, my apologies. And so that'll take you up to this line. And then the demand during lead time is this portion right here. And where does this come from? Well, this is the reorder point, as we've mentioned. And this here is the lead time. This is how long it takes to arrive. And the amount of demand that's drawn down during that amount of lead time is this vertical line. So you can see here, the reorder point equals the safety stock plus the demand during lead time. All right. Periodic review. Again, we have, this is a little complication in what we're expanding on what we had before. This time frame here is cycle T, and the maximum level here is going to be the reorder point plus the average demand during the cycle T. Periodic review. So just to summarize a couple facts about the periodic review, you can think of this as once a month, for example. Periodic review sounds overly complicated. So once a month, you're checking the status of your inventory. Again, the cycle T is the time frame that we're talking about. So one thing that I want to point out in this model has to do with the safety stock. Safety stock is going to be higher than in a variable review type of model. The reason is that a periodic review policy must have stock out protection until the next order arrives, which is an order interval plus a lead time away. The continuous review policy only needs to protect the span of time during the lead time. So for that reason, periodic reviews are going to have a little bit higher safety stock. All right. So this is the last slide. This is kind of the relationship between fixed and time dependent. So if we are looking at fixed value policies, so example of a reorder point or a fixed min max, These might be based on historical average demands or historical deviations. These are units. Any of these things can be translated to time-dependent policies. So, you know, that same kind of min-max or the reorder point might, you know, be translated into some kind of weeks. And then the nice thing is that we are able to then use that number of weeks as a function for future values. So if your forecast in the future is going to be changing over time, and if you have any kind of seasonal forecasting of any kind, this will allow the reorder points, these types of quantities to match what is happening in the future. Okay, right. So there's two areas that I really want to show here. We've talked earlier today about how in the relationship between safety stock and customer service level, the higher you go in terms of the service level, the much more expensive, the exponentially more expensive it costs to maintain safety stock. So for that reason, we want to look at historic demand patterns and identify those products that are either high sellers or have the highest margins. We want to make sure that we are accounting for that. We also want to look at variability. Why? Because if something has very low variability, the way that the safety stock calculation works out is that in general, safety stock will not cost a lot for things with low variability. So what we're going to do here is just kind of run through how this is set up. Now, we can have any number of scenarios here, but you know, this one is defined as inventory planning. We're going to do this analysis at the product and location level. And there's a couple things I want to show here. One is that the quantity that we're going to be doing this on is called usage. And by usage, I'm referring to anything that consumes inventory. That might be shipments, that might be components, that might be STOs or you know, stock transfers to other locations. So we have a quantity in this model called usage. More often than not, this is just shipments, but I'll just put that out there. The Pareto is simply an ABC. We can define it how we want in here, but we're calling it the simple 80-15-5. And the variability is going to be, it's a covariance measure, and it's split out this way. If it's as covariance higher than 1, it's going to be high. And again, any of these are editable. So the result of that, this kind of thing runs in like a batch mode every night. It pushes the results into these attributes, inventory ABC, inventory variability, that we can then use for some kind of downstream processing. So this segmentation it's very useful for demand planning, but it's also very useful for inventory planning. So let's take a look at the target calculations. Now, what we have here, pull this up quick, is looking at the information by product and location. We're going to, the high level grouping that we will touch on, you can kind of see it back here. The high level is that we're defining this at the business, inventory ABC, and inventory variability level. This is the same thing that we did, that we were just looking at a moment ago in segmentation. And we're going to basically break out these categories by which we can then define customer service levels and then any other high-level guidance that we want to provide in order to calculate the appropriate safety stock levels. Okay. We feed it other things, lead time. If lead time variance is not available, which commonly it is not, we can substitute a range and a probability. We have here standard costs in the model, as well as ordering costs and holding costs. And in this case, I have defined the forecast as, I think that it began with just like a simple forecast. It might be the consensus, the final forecast coming out of demand planning. It may be something that we read in from some other system. In this case, I just chose something that's 10% higher. Okay, so we configure the particular scenario in this way, and we get these results. Now, this is just the parsing of information. If you click on any one of these, you see all the product location pairs that are underneath that. Now, we have two businesses. One is commodity, one is the specialty. And then we have a number of ABCs by low, medium, and high. Any of these values in here are going to be editable. You can change any of these, or you could change them at a higher level and then apply the changes, and it would just, you know, expand across the whole thing. And then these are different types of approaches that we can do in order to drive the creation of the stat forecast. I'm not going to touch upon this here just because we're not enough time. But what I want to show is a couple things. One is that the results look something like this. Now here we are, in this case, what am I doing here? So this scenario is the high forecast scenario, right? I look at the information here. The chart can be really anything that we want it to be. We can see here that we have, you know, forecast, we have safety stock units, and the value. The value is really the you know, multiplier by the standard cost. The safety stock days, we talked about that. It says 0, but I think it's actually around 30-something cents. It's just rounded down. We've got the calculation of the EOQ as well as the reorder points in terms of units. All right. So this is nice, but what we can also do is compare that against a situation where we've got the base scenario and we've got the high forecast scenario. So in this case, I mean, we really can see how the high forecast information is here, the base scenario is here, and the numbers can really drive from there. And do one more quick example. Really getting close on time, but I think that this one is interesting. High level forecast, I'm sorry, the high service level and the low service level. Trust me when I say that with the high service level, I gave the A's 95 service level, B's 90, and the C's 85. And for the low service levels, it's just 10 less respectively. So what we can see here is that the forecast is the same, but the safety stock units for the the low service level is going to be considerably lower than what we're seeing up here for the high level. So this can really help drive decisions around the amount of inventory that you can hold or would need to hold for a particular service level. It also is, how much is it going to cost you, for example, to maintain some amount of service. Okay, so let me bounce back, if I may, to here. Going to do a quick summary. Think back to the customer order decoupling point. That anything to the left of that, upstream of that, is going to be a forecast-driven activity, whereas anything to the right is going to be an order-driven activity. It's going to be pulled. Inventory is, there are two that I really focused on. The safety stock, it's going to protect us from uncertainties in lead times and demand. And again, the customer service level is a key component of that, buffer or suffer. Cycle stock, it's directly linked to the replenishment policy through the reorder point, lot sizes, and ordering frequency. With respect to replenishment policies, the reactiveness, which is beneficial for your business, may also cause problems for your suppliers. So it's good to think holistically about these things, think about the partnerships that you have with your suppliers, and choose the process that works best for you. All right.
All right, so thank you so much, Peter. We have some questions coming from our audience, but I would also like to open the line for the rest of our audience who want to ask some questions. So the first question I would like to ask you, Peter, is about safety stocks. So during periods of high uncertainties, for example, like COVID, how can you safely predict safety stock levels?
That's a good question. Safety, so I guess I think you phrased it as safely predict safety stock lessons. I think that there's really, the good thing is that safety stocks are geared for managing uncertainty. That's the basis of it. Because COVID has impacted the business world as much as it has, I think that instead of doing analysis that runs over the past year, which is typical, we might shorten that time frame. Understand that the past 6 months may be more indicative of what the future will hold as compared to the last year. So I think that fairly simple step may bring you a long way towards adapting to what's happening right now. But without a doubt, the safety stock is going to go up.
Got it. So also, how do you decide on safety stock levels without compromising on customer service levels?
Well, it's always going to be a compromise. So I think it's a matter of identifying where you are in your market and what kind of service you want to deliver. Do you want to be a low-cost kind of seller, or do you want to be relied on by your customers? So there's always going to be a trade-off. I think a lot of this is going to be driven by market conditions as well. If you're not able to provide product to your customer, but you have competitors that will, then it's either, you know, you have to make the choice whether or not to be in that market or to step aside. If you're going to stay in that market, then you have to match the service that your competitors are doing.
Got it. Got it. Thank you so much, Peter. It seems like we are running out of time, so I would quickly like to advise our customers who are listening, or our audiences who are listening, that if you would like a product demonstration on how Arkieva can help you achieve a better planning process, please visit our website at www.arkieva.com to request a demo or identify that during their webinar survey, or simply email me with that request, and I will be sure to get back to you. And if you also do have some questions, please, you can still type it in the chat window, and we would reach out back to you personally to answer those questions. We do appreciate your time so much, and we want to say thank you, Peter, for joining us today, as well as thank you to our cherished audience who took the time to join us today. Have a great day, everyone. Bye-bye.